Thank you for having us here, Erin. We're going to talk today about the scalability of regenerative principles. First, I'll introduce myself and then I'll have Andy introduce himself. My name is Carri Beer. I'm an architect. I've been doing what I call earth love architecture for about 28 years now. And so I focus on architecture that is healthy, energy efficient, restorative, it basically creating healing spaces for the people and our planet. And so I do mostly small projects, residential, small commercial, renovations, new. So we're going to go through some of those projects.
Great.
Andy?
And I'm Andy Allwine. I am also an architect and a certified passive house consultant working with Passive to Positive. We're our passive house, a low impact energy consultant firm focused on zero carbon and all things low energy. So yeah, great to be here, Erin.
All right. So Andy you're going to have another presentation where you discuss passive house and regenerative principles. So if you're curious about what exactly the principles are, I would suggest watching Andy's other presentation. But the reason we wanted to talk about scalability of these principles is because it's important to understand how it can apply to any project. Anything in the built environment can have a positive impact. And it can be part of a culture shift to a healthier and more resilient environment and climate for people and planet. So we're going to go through a series of our projects, just kind of talk about what's special about each of them. And I'm going to start very small. I'm going to start with a bunny hutch and a greenhouse. Both of these, they may not look super glamorous here, but they're both made completely out of salvaged and natural materials. So all the windows were pulled out of the house and are reused. The overall structure was our big window crates, salvage siding, random pieces of board. And the only thing new on both of these is this metal roof. That was something that we could not find salvaged. Both of these, one of the key principles is passive solar orientation. So both of these are oriented south-facing. This greenhouse is actually against a south-facing stone wall, so it gets great radiant energy to help grow those plants. So that's, and then the bunny hutch also faces south and is designed with an overhang so they don't overheat in the summer, but that they get the great solar radiation in the winter. One of the things I wanted to mention was stacking functions. And what that means is when you design one thing and it has multiple functions, multiple uses. So the bunny hutch, I don't know if there's this like little triangle piece here. That's a big composter. So all like food waste is composted here. And that gets up to about 140 degrees. So in the winter, when we're composting here, that helps heat the bunny hutch to keep them more comfortable in the, really cold season. And then below the bunny hutch is a collection of their poop and their pee, which we then pull out and use for compost. So that's by stacking functions, you're like all these things are happening in this one little building. So that's that one. Next, I'm going to go to a tiny house. So this is out of scale that we can it allows us to explore everything that's possible. So it's also kind of an R&D project. We're looking at Again, first we started with our passive solar orientation. So this would be south facing with a deep overhang. We've got our solar panels. We're also looking at making something like this off grid, so completely self-sustaining. So you're collecting rainwater, you're filtering it, reusing it. You've got composting toilets. And so all your water is treated on site, or you don't have water because you have a composting toilet. All your energy comes from the solar panels. So this is meant to be kind of a self-sustaining little house. And the idea also is that it's all biogenic materials, meaning ideally it would just, when you're done, it just kind of composts. There's nothing toxic or inorganic here. So this is kind of a fun way to really look at all of these different principles and just incorporate them in this one little module. Kind of next in scale is the row house. We have a lot of these here on the East Coast. Row houses are great because assuming that you have occupancy on both sides of your row house, which isn't always the case, you have those shared walls and only two exposed walls. So you can insulate and air seal those exposed walls, get a really highly insulated envelope. And by doing that, our goal is to achieve net zero in terms of energy use. Row houses are, even though they seem simple, we found that they're all actually very, very different. So they prove a little more difficult than you would think, but it's a good challenge to make all this row house stock use less energy, and again, using natural and salvaged materials. We don't use foam on our projects where at all possible. So when we're insulating and air sealing, we use non-foam products. And then this one, again, I have water capture and reuse. So we designed a water system to capture the roof runoff, store it in a rain cistern, and then be able to water any landscape on the site. And that also prevents like flash flooding and runoff that we then see that goes into the bay. So then the next step up, I'm going to talk about residential retrofits. So this was a 1954 stone house that had an average Baltimore, gas electric bill of on average about $600 a month. This house is now net zero. Again, it was built in 1954. So the point I want to make is that it's possible. We have the knowledge we have, and it's not even about technology, it's about using the right products and training people to do high performance construction in order to get get our existing housing stock to a point where it's not using energy, but also it's helping with low-income families when you don't have a huge energy bill, like you have that money in your pocket. So residential retrofits are a huge part of what we do. A lot of people want to stay where they are. They love their homes, but they want to do something good for the environment and, reduce their bills. So it is possible to do that. And then we have our new single family homes. So of course, this is a blank slate. We can do whatever to make these houses net zero. Again, the first two principles of passive house and regenerative design are our orientation. So this house, the side with the most glazing faces south. But you can't just put all your windows on the south without having overhangs because that's going to prevent the high summer sun coming in and overheating the house. But it allows the low winter southern sun to come into the house and heat up. So again, this house is foam free. We did not use any foam in the insulation for this house. A lot of local materials were used, and this house, it's 1,800 square feet, and with these solar panels on the roof, it actually produces more energy than it uses. So this particular house is positive energy. This is another house we did in out in Western Maryland. It's a little bigger, but again has the same principles of passive solar orientation. This is the south-facing side with the overhangs, the highly insulated and air-sealed envelope. This client were avid bird watchers, so a lot of this was keeping the native landscaping and creating views so they could just sit here and watch the birds. So again, this one was foam free. And because this was a little bit bigger house with this size solar system, it was not positive, but it was net zero. So they have no energy bill. And then I'm going to go into some of our smaller commercial projects. This one is an environmental education center. It was originally just an unfinished timber frame barn that we retrofitted. We did a deep energy retrofit. So we did the air seal and the insulation. Fortunately, this was originally built to face, all these windows here actually face south. But we had to extend that overhang so we weren't baking people in the summer. So we did small modifications to the exterior design and then did the air seal and insulation and just really tightened it up, again, using salvaged materials, natural materials. And then this project is net zero as a community education facility. And one thing I like when we do commercial buildings, especially at this scale, is the educational aspect of it. So we design things that can be seen or that can tell a story. So when you have the community coming in, they're able to learn from a building. So that's a big part of what we like to do as well. Oh, this image is bad. This is another small commercial building, small retrofit in Baltimore of a row house. Again, the same principles of insulating the existing envelope, no foam, using a lot of salvaged and natural materials. This one was not fortunate in that it faced south. This big wall actually faces directly west. So it's kind of hard to tell in this image, but because of that, we wanted to come up with a creative solution so that we're not overheating the space or causing a lot of glare in this office building. So it's, as I said, it's kind of hard to tell, but we angled these windows slightly in the opening to just kind of give it a little more shade, take it off that direct western glaring sun, and help with our energy demand. So that is my half. Now, Andy?
So that was great. I'm going to go through some of our, I guess, some of these are commercial, most are residential, but they're mid-scale to kind of the larger scale, and we get all the way up to like neighborhood scale projects. And I think it's great to see, Carri, your presentation, you going through the principles, because a lot of them, as we knew, are start to overlap, and you'll see some of those same patterns arriving in these larger projects, although there are obviously some different, maybe not more or less, but different types of constraints that are put on these larger projects. So I'll start here with the Prince Street Community Hub in Lancaster, Pennsylvania. This is a 18,000 square foot shelter building in the design phase, and it's aiming to meet FIAS passive house criteria. The client, the Lancaster County Housing and Redevelopment Authority, sort of laid out two clear goals for us. One, minimize operational costs, and two, ensure resilience. So this building is, it includes a 30-bed family shelter, 20 transitional living units, a day center, a health clinic, laundry facilities, office space, and it serves as the city's primary code red, code blue, extreme temperature overnight emergency shelter. So there's a lot going on in this small space, smallish space, and it's complex, 24-hour sort of variable occupancy schedule. And it's really what's driving the energy loads in this building and is becoming our primary challenge for this project. So one of the strategies that we're currently looking at doing to address this is using a VRF, a variable refrigerant flow mechanical system, which will hopefully be able to share some of those loads across the building as one program shuts down and the other opens up. So this building also serves a critical function for the community, obviously, and so resilience is crucial, especially during extreme temperatures where power outages are more common. So we are currently exploring with the team the possibility of battery backup system with a rooftop PV array to supplement or replace even a fossil fuel generator. This is a tight in urban infill site, and so there's really no room for any backup power systems, like physically just no room for it. So that's a challenge, and to address that, we're working to try to minimize the size of that backup system that might be needed, whatever it is, by focusing on reducing the loads and passive survivability, which is the ability for the building to maintain safe indoor temperatures, even during outages, with minimal reliance on any backup system. And of course, the way that we're approaching this is through the passive, airtight, highly insulated envelope and thoughtful window shading. Next up is, getting slightly bigger, is the Weinberg Commons in Washington, D.C. And this was the first certified passive house retrofit project in the U.S. It consists of 3 apartment buildings with 37 total units of affordable and supportive housing. Again, another retrofit. I don't know if I mentioned the Prince Street was a partial retrofit. This is full retrofit. There were several constraints due to that. One being poor building orientation, and that we just can't change that. The buildings exist as they do. 2 is the need to maintain existing usable interior square footage. And then the owner also had the goal of minimizing the use of high embodied foam products where possible. So to address these in a holistic way, we used dense packed cellulose for insulation instead of rigid foam, which reduces the embodied carbon footprint, but it also reduces the R value, meaning we need a little bit more of that insulation. Vertical trusses, as you can see in the upper right, were bolted onto the exterior of the existing brick. So that creates the cavity for the insulation, and it's on the outside, so we're not building inward. So that takes care of some of these goals. These trusses created sort of a deeper than usual exterior wall cavity that allowed us to create an innovative facade integrated shading and solar access solution, which you can see here, and was a key feature really in the passive design. And it helped the project to overcome the poor solar orientation of the existing buildings. The southern facing window jambs, which you can see on the right-hand side of these diagrams and photos, are cut away and sort of angled to capture more of that winter sun as it comes around the building, right? And then on the right hand and the upper side, we have this facade integrated sort of upside down L-shaped shading device at each window that provides summer shading for that high summer sun. So if you're looking at the diagram that shows the heat loads in the bottom there, the red and blue, during the winter heating season, when it's in red, we can see that we are eliminating shading more or less to maximize the free solar gain that we can get. And then in the summer, of course, the opposite is true. Those L-shaped shades start to block pretty much all or nearly all of the sun, reducing cooling loads in the summer. And then you can see in the shoulder season, so this design really worked so well, it adapts throughout the year as those cooling and heating loads ramp up and down. And these are working, along with the other passive technology or passive approaches. The building owner has been able to report energy loads as low as only 6 tons for heating and 9 tons for cooling for the entire building, which is 12 units more or less per building. Next up here, we have another retrofit, Nagley Avenue, which is a retrofit and addition to a historic synagogue in Pittsburgh. This is designed, or was designed, this is constructed, and it was designed to be FIA certified. It is design certified, but unfortunately it fell short on its final airtightness test. And it's unclear exactly why or where the major leaks or the problem leaks are. But there is some existing exposed stone on the interior that was to remain exposed for aesthetic reasons, and that posed challenging during construction and may have contributed to some of the additional leaks that just put us over the edge. Despite not achieving final certification, the project did have or does have notable success, particularly in reducing embodied carbon. It's a reuse of an existing building, so that's a great place to start. We use salvaged polyiso insulation and blown in cellulose on the interior of existing walls. And we used cellulose and wood fiber insulation on the new walls, which are those sort of gray siding that's popping up above the stone. So both of those assemblies end up being carbon negative assemblies. And we even tried to, reuse where possible. The existing windows from the old building have all been salvaged for a future phase greenhouse that'll go on the site. And speaking of future phases, the next phase is actually the rotunda, which is that circular building on the right-hand side. And that will be designed and constructed to meet passive house standards. And there are plans to have a battery storage system that'll allow it to serve as a resilience hub for the building's occupants. Okay, 11 East Lenox Street is a 34-unit apartment building. It's Boston's first ground-up mass timber building. So it's a really exciting, sort of groundbreaking project here. The combination of passive house and mass timber provided some of those stacking uses or cascading benefits that Carri was talking about that allowed the project really to pencil out in a lot of ways. The high performance envelope allowed us to reduce the size of the HVAC system, which in turn simplified the ductwork distribution and design and avoided large penetrations through the beams. This is ideal, of course, for the design of a wood structure. But the minimized ductwork penetrations also, along with this unique double beam detail that the structural engineer worked out, that you can see in the lower right corner and maybe some photo and maybe some others. But these two uses together allowed us to use smaller wood structural members, and that reduced the floor-to-floor height of each floor and of the building as a whole to keep the building under 70 feet, avoiding, going into high-rise code requirements, saving more costs and complications. The shorter wood structure is lighter than concrete and steel, so that allows for a smaller, cheaper foundation. And wood has better thermal performance than concrete or steel, so that helps to reduce the impacts of thermal bridging at the envelope, further reducing the need for added insulation. Finally, the efficient ductwork distribution, again, allowed us to minimize areas of drop ceiling in the units. So this allowed for more exposure of the natural wood of the structure, which was not only beautiful, but it avoided costs on unnecessary interior finishes, drywall, furring, paint, everything. So altogether, these reductions of material use go a long way towards reducing the project's costs and embodied carbon footprint. Okay, finally, we have Berry Farm. This is one of our largest projects, and it covers really an entire neighborhood in Southeast DC. It includes a 108 unit 4/1 podium apartment building, a 139 unit mixed use 3/2 podium building, and a 10 building 92 unit townhouse development. And those are just the first 3 phases. There's more to come. The various building types here means that there were a whole host of compliance pathways to meet, including Passive House, Zero Energy Ready Homes, and Washington's local Appendix Z Net Zero Code, which we actually found to be the most challenging of all of them. And it took a lot of modeling and I guess I'll say strenuous team collaboration to get there. But I think those efforts are going to really pay off for POA and for the residents. POA, the developer, is a nonprofit, so the passive measures that we applied to this project were also geared towards minimizing costs. Passive House certification pretty much guarantees fairly low utility expenses, which in this case, directly benefited the residents. We're also on this project optimizing construction costs by simplifying the wall assembly without compromising performance. So these large high occupancy buildings are really driven by internal loads, and that means that we can kind of get away with less not a non-super insulated traditional passive house assembly. We have a 2x8 wood stud with dense packed cellulose, and that ended up being sufficient for these buildings. And it meant we could avoid continuous outboard insulation, saving a good deal of money. Strategically reducing the envelope, though, means that you have to be very careful and pay special attention to thermal bridging, vapor control, air tightness, both during design and construction. And so there's a lot of upfront work and then again in construction that goes into that. And there's plenty of interesting details that I would be happy to share. And also lots of difficult lessons learned that will be carried into not only the future phases of this project, but also all of our future projects. So in addition to Passive House consulting and modeling on that Berry Farm project, Passive to Positive also provided extensive load calculations for the neighborhood district geothermal system that's going to be installed. So interestingly, due to the high levels of performance across all of the buildings, the loads that we found that the loads were driven by internal gains and occupancy, as I mentioned, making cooling the dominant load pretty much year round. So you can see in the diagram to the left, the cooling load is the blue that's below the red line, and any red lines above that middle line, 0 line, are heating loads. So you can see pretty much all of the year we're in cooling mode. This imbalance allowed us to not only shrink the heating system, but it actually ended up being so unbalanced, as you can kind of see here, that we found that if all the heat from the buildings were to be rejected into the well field every summer, year after year, there's just not enough heat of that heat being pulled back out during the winter heating season. The season's not long enough, and there's not enough time for that heat to dissipate into the surrounding earth. This led the earth around the well field, or would lead the earth around the well field, to increase in temperature year after year, reaching upwards of 100 degrees within a few years, which is obviously not good. It doesn't sound good, and obviously it doesn't sound good for the ecosystem, but it also risks massive inefficiencies and ultimately failure of the geothermal system. So to address this, we're adding a hybrid rooftop heat rejection system to support the well field. This was really an unexpected result of having multiple similar high performance load types tied together. And they just kind of like worked off of each other. So in future projects, we would look for mixed loads to combine to help balance the system. These would be things like domestic hot water or food service or heated pools, things that could use that heat and can reduce the need for additional rejection equipment. So that's our biggest project. So with that, I'll, say thank you for watching this. Hopefully, we were able to highlight the benefits of both regenerative design and passive house strategies, opportunities and the challenges applying them at different scales, and to different building types, commercial, residential. Um, we think in practice that these conservation measures are some of the most impactful forms of sort of climate technology that we have, to help us reduce carbon footprint and make buildings efficient and adaptable for the long term. So here are our contact info. And I think it's on the Climate Tech Plus website as well. So please feel free to reach out. As we said in the beginning, and Carri noted, we offer architectural services and energy consulting services at all scales, as you've seen, and we'd be happy to talk through any projects that you all have. So thank you very much.
This is great. Carri and Andy, thank you so much for your presentations. Very insightful. Do you have a few minutes for a couple of questions?
Sure.
Sure. Yeah.
Okay, great, great. So yeah, Carri, I have a few for you, and then Andy, I have a few for you as well. The bunny hutch.
Always a popular one.
At first, when I was on the screen, I wrote down what is a bunny hutch, but you explained it, so I thought that was really very cool. Thank you for showing that. And I love the off-grid tiny house as well.
Mhm.
And the fact that there's, embedded circularity into the property,
Right.
and the biodegradable aspect of it. And then you talked about completing a 1956 deep energy retrofit of a
Yes.
property. How long does that process take?
Well, so full disclosure, it's my house. And we've done a lot of the work ourselves, partially for affordability's sake and also to learn. Um, so we installed triple pane windows that were very, very heavy in existing masonry openings. But by doing that, we were able to then inform our projects and help our clients,
Mhm,
help
mhm,
contractors. Um, I mean, the house we touched every surface. So I would say it's for us, it's been about an 8-year process. That's
mhm,
not that's not for everybody, but I do a lot. I consult a lot with homeowners, and they want a master plan.
mhm,
Um, because I think there is some stuff they want to do themselves, and like people don't have tons of money all at once generally. So it's like, where do you start? And usually it's like, well, let's start with air sealing and insulation. And there's kind of different criteria, and a lot of it, a lot of my those residential retrofit clients do take, you know, 5 years
mhm,
on average to
mhm,
really get a full retrofit.
mhm, mhm, mhm. Yeah, so yeah, I love it. I love it. So, start with the envelope first is what I've always heard,
Mhm.
right?
Yeah.
And then you're doing some new single family homes as well. Are you finding, because I'm looking for, and I know other people watching may be looking for like a urban infill
Hmm.
solution for some of these vacant lots in Baltimore City,
Yeah.
specifically looking at offsite construction as well. What are you kind of seeing out there in the landscape when it comes to urban infill?
I know there is a push for, so the panelized systems, which I don't disagree with. I think, we've looked. I think that's one option. The Baltimore has a panelized manufacturer here. We've been looking to bring one, like a seed startup for straw panels to do panelized construction. So it's more locally owned and using all natural materials. So I do think that that's a possibility, especially on vacant lots, you know, where you have the space, or not the space, but you're not. I think if you try to put it in between two row houses, that's not, you can't use the panels because nothing is straight.
Right.
So I think panelized works when you have, you know, a group of 3 or 4 in a vacant lot. We also have, you know, a lot of builders are, you know, they price it as a stick built and it's sometimes cheaper. So I think it depends on yeah, on a couple of things, but
Yeah,
it is an
I'm
option.
excited. I'm excited about the opportunity for more options. You know, shouts out to Blueprint Robotics who are doing big things in Baltimore.
Right.
But they're more so panelized, more so multifamily, um, and more so for maybe not necessarily affordable housing per se, from what I've seen. So there is definitely room for maybe a volumetric factory or some other
Hmm.
options here in Baltimore. So I'm excited to see where that landscape takes us
Yeah.
uh, for affordability. And then a lot of your designs are kind of net zero energy. Where does net zero carbon come in, or the purchase of carbon offsets? How does that play into your work, if at all?
Um, I mean, at a residential, single residential scale, I mean, I personally don't, I'm not looking at that at the
Hmm.
moment. I think,
Hmm.
you know, probably Andy Scale and um, you know, they're looking more at carbon offsets.
Hmm. Hmm.
So
Okay. Yeah, I think from both of your presentations, I kind of am firmly seated in the, health and wellness of building occupants, real-time indoor air quality monitoring. And I know that that's one of the great things about, the work that both of you do is it really creates a tight envelope. But I also believe that the air quality monitoring is kind of that validation that you're getting, kind of what we've paid for at the end of the day. Which for the most part, we're finding that it's really the affluent that can afford to do a lot of these types of retrofits or be able to purchase these types of properties. But we're also seeing from some of the other presenters that, there is an affordable model, lots of subsidy, but an affordable way to kind of get it done as well, which I think is very
yeah,
exciting.
I think a lot of that falls into education and you know, if you want to talk about lessons learned, I think education of our contractors and tradespeople, um, because some of the product isn't necessarily more expensive. And if you know, usually if someone hasn't installed something before, they're going to charge you more to figure it
Mhm.
out. So one of our goals as a company is to help with that workforce development, help get these high performance building techniques in the hands of like local workforce. So it's not something that only the elite can afford because they can afford the markup on people trying to figure it out.
Hmm. Hmm.
Um, so
No, I
yeah.
appreciate that. I appreciate that. So, Andy, I've got a few questions for you, and Carrie, I know you've got to run shortly, but if you tap out before we're done, we totally understand.
All right.
We have your contact information on the screen and encourage everyone to reach out as well. So stay on as long as you can, and
All
and
right. Thank you.
I'll ask Andy some questions as well. So, Andy, great presentation as well. Weinberg Commons in DC. I love it. I've only seen samples of that work out in Germany and the Netherlands where they're using more of a offsite um, panelized methodology for exterior cladding. I hadn't quite seen it quote unquote stick built on site the
Mm-hmm.
way you did it there. And I guess my question is, how did your team overcome the tenant disruption challenges?
Well, I don't believe this is a little while ago, so I I don't believe that there were tenants.
It was
Uh,
vacant.
in the building at the time. Yeah. So so that obviously makes it a lot easier. And yeah, you're right. I've seen like I know the Netherlands has a great program for and I've seen some great projects in New York City as well, where the tenants need to remain in place. And so you come in from the outside and you do everything, including really MEPs on the outside in some cases. But yeah, in this case, we had a vacant building, so it made it a bit easier. But they still, like I said, they still didn't want to, lose a whole lot of interior square footage, which is understandable.
Right, right. And then so I guess for energy modeling purposes, because it sounds like both of you do a good share of energy modeling as well. So for existing buildings, like how do you bring that in? Are you creating digital twins of the exterior of the building for energy modeling, or like how do you bring an existing asset into Energy Plus or whatever software you're using?
Yeah.
Uh,
Yeah, so we'll typically run a few iterations of it, and yeah, try to get a baseline for the existing building, and then I mean, part of our process for really any of these strategies is to think through um, in most cases, it's like small steps, manageable steps that we can take to make really significant differences, whether that's for energy purposes or for something like embodied carbon.
mhm.
And so, yeah, we'll start with the baseline existing building, and then kind of start to work our way up to the level that we want to be at.
Hmm.
Yeah.
I mean, you two are my go-to resources for building homes in a very, earth-friendly way. Earth love, I think, is what Carrie said in the beginning. I love that. Because I'm kind of new to the space, especially passive house, and you guys are kind of my go-to on that. My question is just kind of I see passive house, and correct me if I'm wrong, is kind of a design-based standard, similar to LEED in the sense that LEED being a design-based standard in the sense that you get your badge, and then that was based on design, and then how the building performs is a totally different story. And if it could be an energy hog, LEED
Mhm.
Platinum building
Right.
like the Bank of America building in New York, that you don't lose your badge because it was based on design.
Yeah.
Um, whereas Energy Star is something different in the sense that it's performance based, that if you fall out of your Energy Star rating, then you have to rejigger the building to be able to kind of get back to Energy Star certification. How is Passive House in regards to, it sounds like it's based on design, you get certification based on design, but then how do you monitor performance at the end of the day, if that makes sense?
Yeah, and it is based in design, in that there's design principles that we're following, but it is a performance standard, more akin to Energy Star than LEED, where LEED is prescriptive and you meet these
Hmm.
certain criteria. So
Hmm. Hmm.
it with Passive House, you can kind of do whatever whatever you need to do
To
to hit
get
the
there.
target.
Yeah. Hmm.
And then there's testing at the end of the day, multiple layers of testing, and eh, during construction, there's a rater or a verifier involved. So there's a lot of sort of QA, QC, FIAS themselves are involved in reviews. So it's a high quality of quality assurance in the standard that you're getting what you paid for. But yeah, it's kind of currently it's set up where you know you test out at the end, you pass, and you're passive house certified. And then it's kind of up to the building owner or the local jurisdiction if there's requirements, what kind of monitoring goes on. I know that the FIAS, I can't speak necessarily to Passive House Institute, PHI, but FIAS has put out a revived standard that does have a certain amount of monitoring and ongoing sort of maintenance that is involved with that. Um, so so yeah, there's a bit of a difference from some of those prescriptive requirements to the performance based PS
So
program.
there is a situation where somebody potentially would have to recertify 3, 5 years down the road, maybe,
Um,
or is it?
not for the typical FIAS passive house certification. That's sort
Okay.
of when once you've
You
passed, and you
passed.
have
Yeah.
a extremely high performing building. And yeah, then it's kind of up to the building owners and occupants to keep it going that way.
Keep it going. Absolutely.
Yep.
So then I believe you had a Negley Ave project in Pittsburgh, I believe. Just trying to take notes while you were talking. The retrofit. So then I think you said that you know, took all the steps to achieve passive house, but because of the age of the building, we're not able to get the air changes to where it needed to be. Was the aero barrier air sealing methodology used to try to kind of get over that hump, or what?
Yeah, and I would say what I don't know that it was necessarily because of the age of the building
Oh,
we didn't quite make, and it wasn't like, there's huge leaks in this building. It's just this is a really rigorous standard that we're talking about, and we were just kind of over the line there, which is fairly common with
mhm.
passive house buildings. But no, I think the aero barrier and aero seal products are really great and useful in particular circumstances. But in this case, it was, and again, I'm not sure if it was the exposed existing interior stone that is the the source of the leaks, but we didn't want to have the aero barrier uh, on that because it's not going to be a nice not going to make for a nice finish after that's done. Uh,
Mm,
no, that really wasn't an option in that particular instance,
mhm,
which again, yeah, to your point, made it kind of even harder to deal with
mm,
that
mhm,
stone.
mhm,
And yeah, so we've used it. We've certainly used it, and it, like I said, it is useful. But in that instance, it just couldn't be used.
So the Berry Farm development, very exciting. I used to live in DC, so I'm fairly familiar with the community there in Southeast, and
Yeah.
wow, that's amazing. That you're taking on such a huge project for this. But I think it's also cool that both you and Carrie are in high demand across the country for this type of work being based here in Baltimore, which is really, really cool. So as we kind of wind down, Carrie, what would you say is the biggest barrier to adoption? I know that on the commercial side, dealing with, commercial building owners, builders, who are the least digitized, declining in productivity can have a strong resistance to change, can be a challenge. What would you say is the biggest challenge for you, or barrier on the residential side to your work?
I would say on the residential side, it's it's a little bit of education. I think it's, we've come a long way. There's a lot, I mean, back when I started this, when I would get clients, I would educate them and be like, "Don't you want to do this?" And sometimes they'd say yes, sometimes they'd be like, "No." But now people are coming to us, which is exciting that, that it's out there enough that people know to ask for it. Um, I mean, me personally, as a architect that does this, I have had the biggest challenge in finding contractors
Yeah. Yeah.
and tradespeople
Hmm.
um, that are interested in doing something new. And it's not even necessarily difficult. It's just, there's this concept that everything has to be, quick and I don't want to have to think about it. I just want to go in and build it and make my money and get out.
Right.
And that's just not the kind of projects they are. They require thought and time. Um, and sometimes, and yeah, that does sometimes add cost.
Hmm.
Maybe 2 to 5% is generally what I see. But then
Hmm.
you don't have an energy bill. Like
Right.
you literally don't have an energy bill. So that savings of $300 to $800 more than pays for, what added that is on a construction mortgage,
Sure.
monthly payment.
Sure.
So getting people also to understand that investment, the concept of an investment,
Mhm.
is sometimes a challenge.
Got to make the
A lot
business
of people,
case.
hmm?
Yeah. Got to make the business case for a lot of folks.
Yeah.
Mhm.
And people don't see, they don't see the insulation, they don't see the air sealing. They see I still have clients that were like, oh, I don't think I want to do the insulation. But then they turn around and buy a, $8,000 refrigerator. I'm just like, no, like, so there's still some of that out there. But I appreciate, having platforms like yours where we can help educate and hopefully bring more people in that are engaged and want to learn and want to make
Yeah.
it happen.
No, it's definitely needed. Andy, same question for you. I guess the building owners that get it, and the ones
Mhm.
that don't, how are you bringing them along?
Yeah, yeah, you're right. We have some really great clients, developers who are, all in, and that's such a refreshing thing, as Carrie kind of alluded to. Um, those that aren't, I mean, there are plenty of, we've been lucky the past couple of years that there have been a lot of incentives out there, whether it's at the state level with LIHTC. I know Pennsylvania and a number of other states offer points on the LIHTC funding formula to hit Passive House, or through the IRA, which has been a
Mhm.
massive boost. And hopefully,
179D 45L definitely helps.
yep, exactly. So who knows what the future brings here, but hopefully that they're popular enough to hang around. Um, and unfortunately, there's not the same incentives for things like embodied carbon out there right now, or at least not widespread. So hopefully, also in the near future, we'll start to see more movement on that end of things, because that's also pretty critical. I guess I would agree on the education and the contractors. We also have been lucky. We have a couple contractors, and it's primarily like on Berry Farm, for instance. We're working with the same contractor in phase one as in phase two, and you really see. Well, I don't know if the you see a difference in you, and again, all those lessons learned, that sort of institutional knowledge kind of comes along with the team, and you see it's just a lot smoother. I'm not saying that it's there's no hiccups and or anything, because subcontractors are going to be different, but having that sort of umbrella over everyone who's gets it. And I think that the data has shown that too. I've seen charts where year after year after, say, Pennsylvania initiated the LIHTC Passive House, not requirement but option. Those prices, right, were at like the 5%, 2 to 5%, like Carrie said, and they start to come
Mhm.
down and start to reach parity with traditional construction, just because there's more education and people aren't questioning it, and or like how to do it. So I think there's that part of it too. Yeah, but yeah, the contractors that we're working with on multiple projects, you really start to see that that come to the fore. So
Gotta have a solid team. Well, I definitely appreciate you both. We could geek out for a couple more hours if only we had the time to be able to do it. But I'll let you get back to your day, and I definitely appreciate your time, your subject matter expertise, your thought leadership on the topic. This is exactly what we're looking for this year's Climate Tech Conference, and so thank you.
All right, thank you, Aaron.
thank you.
Appreciate it.
All right, you guys have a great day.
All right.